Okay, so we are going to kind of cram in a bunch of different very basic things when we talk about algebraic expressions, things that you've already seen and done in Saxon last year. You just may not have realized that it was algebra. It was always on your problems since fourth grade math, honestly. You've been solving algebraic expressions. So we're going to talk about some vocabulary, some terms that maybe we don't know of or maybe heard of, because these are terms you're going to continue to hear about starting this year moving forward. But then you're also going to see how to solve expressions, which are things that you actually already know how to do. And then we're also going to talk about keywords. So whenever we are taking an expression and writing it in word form, or if we are given words and we want to write an expression to represent word form, which we also did in Saxon. So these are all pretty much review concepts that we're kind of doing all jammed into one day, because this is stuff that you've done. It's just kind of review. Okay. All right. The very first thing that we're doing today is algebraic expressions. So make sure that you're open up. This is in the one that you folded in half if you haven't found it yet. All right, the very first word that we're writing down is the word algebra. So algebra is a language. Basically, it's like a math language involving symbols, which include variables. A variable is a symbol, which is usually a letter in algebra, that is used to represent a number. And then an algebraic expression, which you will hear me use that phrase. An algebraic expression contains at least one variable and at least one operation. There is no equal sign in an expression. Equations have an equal sign, expressions do not. Okay? So here's a bunch of examples of what expressions might look like. S plus 120, or Z minus M, or M divided by 6, or 12 times T. Okay, those are all examples of expressions. Now in Saxon, when you saw these, it would say solve for, it might have told you to solve S plus 120 if S equals 5. And you would just replace S with 5. Or sometimes it would give it to you in equation format, and it would say S plus 120 equals 125, and you would have to solve for S. Okay, so these are things that you've seen and done before, but you got to know the difference between an expression versus an equation. So an expression does not have an equal sign. Okay, each part of our expression has different components that make it an expression. So the numbers themselves, the actual digits, those are what we call terms. Both pieces right here. So this number is attached to a variable. That's one term. This number over here is another kind of a term. Okay, they're two different terms. This one has an X attached to it. This is like my X family. This is my this is just my regular plain number family. Okay, so they're two separate terms. Okay, the number that is here, this 5 attached to a variable, is called the coefficient. So the number that is attached to the variable, the number a part of my X family, that X could be a M, it could be a C, it could be anything. Okay, but the number that's attached to it, that is what we call the coefficient. The number that's all by itself, not attached to a variable, is called a constant. And then what is that X called?
Variable.
It's a variable. Okay, so these are the parts of an algebraic expression. These are terms you're going to hear. They are terms that you need to know. And they consist of terms. So whenever we start simplifying terms, we're going to do that tomorrow. You'll see how we keep the X family together and the non-variable family together. Okay, so that's important to remember. We have two separate terms. Okay, on the next page, how do we solve expressions?
You have to put it in.
What to write?
To solve an expression, the very first thing that you have to do is plug in the value of the variable into the expression, and then you can solve it. So in order to solve an expression, you actually need to have the value of the variable, because there is no equal sign. I don't know what it equals, so I can't use the inverse operation to figure out that missing number like how we were used to doing in Saxon. I actually have to be given the value of the variable. So if I look at this one, it's just a reminder, x over 6 is reminding you that fractions are actually what kind of problems? Division problems, right. So a fraction is a division problem. When we are working in algebra and doing algebraic expressions or equations, and you see a fraction, it actually means you're dividing. So it is considered a division problem. Okay, so whatever x is, if I said x is 12, I would plug in 12 for x and I would divide 12 divided by 6. My answer would be 2. Okay, when they're touching like the example below where it says 4x, a number and a letter sitting next to each other means that you're doing what?
Multiplication.
Multiply, right. It means to multiply. The word evaluate, which is what you will see all the time. Occasionally you'll see solve, but a lot of times you will see the word evaluate, which means solve. But in algebra, they typically change the word solve to the word evaluate. Evaluate each expression means solve it. Okay? It says if m equals 4, z equals 9, and r equals 1/6. So I have a bunch of examples below. I'm going to just plug in the values of each of the variables, and then I'm going to evaluate it or solve it. When I plug in the value of a variable, this part is important. These are very basic expressions, but as you continue to advance in math, your expressions start to get a lot more complicated. They turn into equations, you're balancing equations. So this next part I'm about to show you is important. Start developing these good habits now so that whenever you have these longer expressions and equations, you already have developed this good habit so that you're not getting lost in your math. Okay, hang on just one second. So when you plug in the value of a variable, you are going to use a parenthesis to show me that that m is now what? 4. You are using a parenthesis because sometimes, if you look at this example here, 11r, if I didn't put the value of r inside parentheses and I just wrote 1/6, it might look like 11 and 1/6 instead of 11 times 1/6. That's why we want to make sure that we're putting the value of the variable inside those parentheses to show that I'm replacing a variable with an actual number. Is everybody with me so far? Okay. All right, so now all I have to do is just add 3 plus 4, which is 7. Okay, for z on number 2, what am I going to plug in for z? 9. Remember, put it inside parentheses. What is m? 4. So all I'm doing is just 9 minus 4, which is 5. Number 3, I'm going to plug in 1/6 for r. So if I'm multiplying 11 times 1/6, what's my answer going to end up being?
166.
First, I have to remember, put your whole number over 1, and then you're multiplying straight across. So 11 times 1 is 11. 1 times 6 is 6. It's improper. I can't leave it like that. I got to change it to a... Good. So this is going to change to 1 and 5/6. Okay, y'all try the last 3, and y'all can check with each other, and then we'll check all together. Okay, so on 4, 5, and 6, these are the problems that you should have written down after you plug in the value of your variable. So on number 4, you replace the m with 4, so you are actually dividing 12 divided by 4, so your answer is 3. On number 5, order of operations. First, what is a fraction? It is a division problem. So what that actually means is 9 divided by 3, which is 3, and then I'm going to add 3 plus 7, which is 10.
So it's basically kind of an order of operations with the pizza slice.
Mm-hmm. It is exactly, so Hunter asked me earlier, he said, will we be using like order of operations with algebra? I was like, yes, which is why we did so much practice with order of operations and properties before we started algebra, because all of that applies. You have to remember all of those rules when you're solving algebraic expressions and equations. Okay, the last one is just 1/6 plus 5. So what's my answer going to be there? Yeah, 5 and 1/6. I could divide 1 divided by 6 which is fine. It's going to give me a decimal number, so then it would just be 5 point whatever I get dividing, or I can just leave it as 5 and 1/6. Okay. If I solved this one the same way, 9/3 plus 7, I would still have to change because 9/3 is improper. I would still need to fix that, and you would still end up with 10 by the time you're done with it. Okay. Okay. Last one. This is our keywords. So on this one, we are just doing practice taking a phrase and then putting it into an expression format. So if you look at the very first section, this one is all addition. So we have all of our keywords and phrases, things that you'll see in algebra, meaning we're adding. So something like the word plus, that's obvious. If it says 5 plus 3, then I know I'm doing 5 plus 3. Or if it says, for example, a number plus 3, I would use a variable to represent a number plus 3. That's what my expression would look like to represent that example. A number plus 3. If it says 10 more than a number, more than means that I'm adding 10 to a number. A number is n. 10 more than that means that I'm adding 10. So n plus 10. Do you'll kind of see how that works?
Yeah.
Okay, the next one, the sum of a number and 5. So n plus 5. I don't know what the sum is yet because I don't have the value of n, so I'm just going to write the expression. No equal sign. The next one, increased by a number n. Oh, sorry, I skipped one. I did, sorry. The total of 6 and some number. 6 plus n. Notice how I'm also going in order of how it's listed. Okay, the only one that's kind of confusing is this one here where it says 10 more than a number. Because I start with a number and then it's 10 more than this number. Does it really matter though if I do 10 plus n or n plus 10? With addition it doesn't because y'all remember the name of the property?
Additive.
Close. It's the additive property, but it's more specific. It starts with the C.
It's the commutative.
The commutative property of addition. Okay, so on this one, it doesn't really matter because it's commutative. It doesn't matter the order that you add it in technically because you're just adding them. So it doesn't really matter. Okay, increased by. A number increased by 2 would be n plus 2. And then the last one, 11 added to a number. I could do n plus 11 or 11 plus n. Okay, do we feel okay with addition? Writing an expression based on words, because that's part of your practice today. Okay, next part, subtraction. So we have a ton of keywords and phrases for subtraction. So a number minus 7. Here, order does matter, because when we're subtracting, I can't just subtract in any old order. It has to be specific. So a number minus 7. If that number is 10, I have to do 10 minus 7. That's got to be in that order. Okay, 4 less than a number. How do I write that?
Number minus 4.
Yes, number minus 4. The difference of a number and 3. Number minus 3. 9 less a number. Which one goes first? N, good. Because I'm taking 9 less of that number. A number decreased by 12. N minus 12. I'm decreasing a number by 12. And the last one in subtraction, 6 subtracted from a number. That one's very easy because it tells me exactly. 6 subtracted from a number, so n minus 6. You just got to make sure you read them carefully to understand the order that it goes in. Okay, multiplication. Do you think that this one matters as much as subtraction?
No.
Not as much because of the property, which is named what again? Commutative, but this time of multiplication. Okay, so 8 times a number would look like this, 8n. Typically, we don't do n8 Like, we don't usually put the variable first. We usually always put the number attached to the variable. So it's number then variable. The product of 14 and a number would just be 14n. Twice a number or double a number means what? 2n. Could I use x instead of n? Yeah, I'm just using n because I'm replacing the word number. So a lot of times in algebra, they'll use the first letter of whatever you're representing. So if it's total, T for total, C for cost, M for miles. Okay. A number multiplied by -6. -6n. And then 3/4 of a number would be 3/4 n. Okay, and then division, the quotient of this does matter because you're dividing. You can't just flip-flop it around. So the quotient of a number and 7. N divided by 7. Could I also write that as a fraction? Yeah, because you're going to see it for sure as a fraction. 10 divided by a number. So 10 over 4 as a fraction. It's just really, really small, so I had to draw a little slash as my division symbol. You can do it however. You can write it like this too, 10 divided by 4. And then the last one, the ratio of, because ratios are written like a fraction sometimes, and we know that fractions are division. So the ratio of a number to 15, number to 15, n divided by 15. Okay, y'all ready for your practice?
Is it a lot?
It's not a lot.
Yeah, for kids.